Hi there, welcome back. We are given an example here. Let's look at it. And we are told that the force of the vector of the following magnitudes, 1 Newton, 1 Newton, and 2 Newton for the positive y direction, and 2 Newton, 1.5 Newton for the positive x direction. We are asked to determine the resultant. Okay, so the first thing to do would be to write down a plane for ourselves, a Cartesian plane with our magnitudes. The second step will be to write down the positive y direction newtons. And to do this, I'm going to incorporate the tail to head method, whereby our vectors can touch each other from tail to head. Starting with the first Newton, the second Newton, which is 1 Newton, and the third Newton, which is 2 Newton. The next step will be to write down, with respect to the positive x direction, I'm going to incorporate the tail to head method, whereby the vector will touch each other and be perpendicular to each other. 2 Newton, 2 Newton, and 1.5. And to label my diagram, this will be the final vector. This will be my vectors with respect to x in the positive direction, and this will be my vectors with respect to y. If you look at this diagram here, we are looking at a triangle that we can use a theorem called the Pythagoras. And what the Pythagoras theorem tells us that is that the adjacent and the opposite squared can be equal to our hypotenuse. I will use that law. My opposite squared adjacent squared can be equated to the hypotenuse, which in this case is represented using r squared. For our y, we have 1 Newton plus 1 Newton and 2 Newton. For our x, the adjacent, we have 2 Newton plus 2 Newton and 1.5 squared to give us the final magnitude. This is 4 squared and 5.5 squared. If you punch this into your calculator, you should get. Therefore, the magnitude of the resultant is 6.8 Newton.